Crystal oscillators explained. From DC bias to stable frequency. Chapter 5. Common failure modes and how to debug oscillators. Sometimes, oscillators simply don't oscillate. This is normal. Every non-working oscillator is telling you something. You just need to know how to listen. The most common failure is incorrect bias. If the transistor is off, there is no gain. If it is saturated, the signal clips. Oscillation only works in the active region. Oscillation requires enough loop gain. If gain is too low, signals shrink instead of growing. Losses in the circuit overpower amplification. The oscillation dies out. Correct phase is just as important as gain. If feedback returns out of phase, it cancels the signal. Instead of reinforcement, you get cancellation. Oscillation cannot start. Components matter. A damaged or wrong crystal will not oscillate correctly. Incorrect capacitor types or values can stop oscillation. Always verify components first. Power supply noise directly affects oscillators. Noise can modulate frequency or prevent startup. Proper decoupling is essential. Clean power supports stable oscillation. Even measuring the oscillator can break it. Heavy loading disturbs the feedback loop. Always use buffers or high-impedance probes. Measure carefully. Debugging works best when it's systematic. Check bias first. Then check gain, phase, components, and power. Step by step, oscillation emerges. Oscillators fail for clear reasons. Bias, gain, phase, components, and loading all matter. A working oscillator is the result of careful checks. Debugging is a skill, and it can be learned.